Welcome to our deep dive into neural networks. It seems like you're really keen on getting a good grasp of this whole field.
And you've given us some excellent material to work with for this deep dive.
Yeah, this document you shared is pretty amazing.
It really lays out how these neural networks have evolved over time.
It's really like a journey through the history of AI.
Yeah.
A story of how we humans have been inspired by
Oh, yeah, definitely.
how incredibly complex our own brains are.
Absolutely. The way our brains can recognize patterns
Yeah.
and make decisions is incredible.
It's mind-blowing.
And that's really the spark that led to the whole field of artificial neural networks.
It's fascinating to think that something as simple as
Right.
seeing a squirrel in the forest could lead to such a scientific revolution.
It really is.
So how did this happen?
Well, it was that ability of the human brain to instantly process that visual information
Right.
and identify the squirrel.
Yeah.
And that's what inspired Warren McCulloch and Walter Pitts
Okay.
back in 1943
Wow.
to create the first mathematical model of neurons.
So their work was essentially like a blueprint for building artificial brains.
In a way, yes.
Wow.
They laid the foundation for the entire field of artificial neural networks
Okay.
with their groundbreaking mathematical model of a neuron.
That's pretty amazing. But how did we actually go
Yeah.
from a theoretical model
Right.
to real functioning neural networks?
One of the very first tangible models was the perceptron,
Okay.
developed in 1957 by Frank Rosenblatt.
So this was like an early version of a neural network?
It was much simpler than the neural networks that we have today,
Gotcha.
but it was a critical step forward.
So can you give me an example of what a perceptron could do?
Think of a gardener deciding whether or not to water their plants.
Okay.
The perceptron would take inputs like the soil moisture
Uh-huh.
and temperature,
Okay.
and it would then assign weights to those inputs
All right.
based on their importance.
So certain factors are more important than others?
Like, for example, soil moisture would probably have a higher weight than temperature.
Makes sense.
Right.
So is the perceptron essentially like a scale
Yeah.
that weighs different factors
I got it.
in order to make a decision?
That's a great way to visualize it.
Cool.
And there's also this other element called bias.
Okay.
So it's kind of a baseline tendency.
Okay.
Let's say the gardener is generally cautious and prefers to err on the side of overwatering.
Uh-huh.
The bias would reflect that tendency in the perceptron's calculations.
So it takes these weighted inputs, combines them with this bias,
Right.
and then essentially spits out a decision to water or not to water.
Exactly.
This seems really simple.
It is. It's very
Are
simple.
there any limitations to this model?
Yes, you've hit on a key point.
Okay.
The perceptron, while groundbreaking,
Huh?
had significant limitations.
Okay.
It struggled with what we call nonlinear problems.
Can you give me a real-world example of a nonlinear problem?
Certainly. Imagine trying to predict a customer's likelihood of purchasing a product
Okay.
based on their age and income.
Okay.
The relationship isn't always straightforward.
Uh-huh.
A customer with a high income
Yeah.
might be less likely to buy a certain product
Okay.
if they're also very young,
Okay.
while a customer with a moderate income
Uh-huh.
might be more likely to buy if they fall within a specific age range.
So it's not a simple case of
Yeah.
more of this equals more of that.
Exactly.
Okay.
Those kinds of relationships where a simple straight line
Uh-huh.
can't represent the pattern,
Yeah.
those are what we call nonlinear problems.
Okay.
And the perceptron just couldn't handle that level of complexity.
So what happened next?
Yeah.
Did researchers just abandon the whole idea of neural networks?
No, not at all.
Okay.
They recognized the potential
Mm-hmm.
and focused on overcoming these limitations.
Oh, okay.
And this led to the development of multi-layer perceptrons, or MLPs.
MLPs. Okay, so these sound like a more advanced version of the perceptron?
What's the key difference?
The main difference is the introduction of what are called hidden layers.
Okay.
Instead of just having an input and an output layer,
Uh-huh.
MLPs have one or more hidden layers in between.
So it's kind of like adding more steps to the decision-making process?
Precisely.
Okay.
Think of it like this.
Yeah.
With the perceptron, it's as if you're trying to make a decision
Uh-huh.
based on a single piece of information.
Okay.
But with an MLP, you're gathering information from multiple sources,
Yeah.
processing it through these hidden layers,
Uh-huh.
and then arriving at a more informed decision.
Gotcha. Can you give me an example of how these hidden layers
Yeah.
would work in practice?
Imagine a bank using a neural network to automate loan approvals.
Okay.
An MLP could take various inputs like income,
Mm-hmm.
credit score,
Yep.
debt, and work history,
Okay.
Each hidden layer would then process those inputs,
Okay.
looking for complex relationships between them.
So it's not just looking at each factor in isolation.
It's analyzing how they all relate to each other.
Exactly.
Huh.
For example, the network might learn that a high income alone
Mm-hmm.
doesn't guarantee loan approval,
Okay.
but a high income combined with a good credit score
Yeah.
is a much stronger indicator.
It's almost as if the network is developing its own understanding of what makes a good loan candidate,
Uh-huh.
just like a human loan officer would.
You got it.
That's impressive.
Yeah, those hidden layers allow the network to move beyond simple linear relationships
Huh.
and make much more nuanced decisions.
This is really fascinating.
It is. It's a fascinating field.
But how do you actually train these complex MLPs
Right.
to make accurate predictions?
Well, that's a great question.
Yeah,
And that's where the beauty of backpropagation comes in.
that propaganda.
It's an algorithm that allows these MLPs to learn from data.
Okay.
It was a major breakthrough developed back in 1986 by David Rumelhart, Jeffrey Hinton, and Ronald Williams.
Backpropagation.
Yeah.
That sounds a little intimidating.
It sounds a lot more complicated than it is.
Okay.
It's actually a pretty elegant concept.
Okay.
Let's go back to our loan approval example.
Oh, okay.
Imagine the MLP predicts
Yeah.
a 70% chance of approval
Okay.
for a particular applicant,
Okay.
but the bank ultimately approves the loan.
Mm-hmm.
Backpropagation takes that error,
Okay.
so the difference between the prediction and the actual outcome,
Gotcha.
and uses it to fine-tune the network's weights.
So it's like the network is getting feedback on its performance
Exactly.
and learning from its mistakes.
That's a great way to put it.
Okay.
And what's really amazing about backpropagation
Yeah.
is that it adjusts the weights across all the layers,
Okay.
from the output all the way back to the input.
So the entire network is learning and improving.
Precisely. It's a continuous process of refinement.
Makes sense. What about images, though?
Right.
How do neural networks handle something as complex as visual data?
That's where convolutional neural networks, or CNNs, come in.
So
Yeah. They've really revolutionized the field of computer vision.
are they designed to specifically see images?
You could say that CNNs are inspired by the visual cortex in our brains,
Mm-hmm.
and they're incredibly effective at processing visual information.
I'm curious about how they work.
Yeah.
What makes them so good at understanding images?
Let's imagine you're trying to teach a computer to recognize handwritten digits.
Okay.
A CNN would use convolutional layers with filters
Uh-huh.
that slide across the image,
Okay.
almost like a magnifying glass.
Filters like the ones we use on Instagram to make our pictures look better?
It's a similar concept,
Okay.
but instead of aesthetic effects, these filters are designed to detect specific features
Uh-huh.
in the image, like lines,
Okay.
edges, and curves.
So it's like breaking down the image
Yeah.
into its fundamental components.
Exactly, and it does this hierarchically.
Okay.
The first layer might detect simple edges.
Okay.
The next layer combines those edges into corners and more complex shapes, gradually building a richer understanding of the image.
Kind of like solving a jigsaw puzzle.
Yeah,
You start with the individual pieces,
right.
and then you assemble them
Exactly.
to see the complete picture.
And then there are pooling layers
Okay.
that simplify the information,
Okay.
focusing on the most prominent features.
So it's saying, okay, we got all these lines and edges,
Right.
but let's just focus on the ones that
Yeah.
really define the shape of
Yeah.
this digit.
You got
It's like a detective, you
Right,
know,
so you-
focusing on the key clues
Yeah,
to solve a case.
that's a great analogy.
Okay.
And finally, all of these extracted features
Uh-huh.
are passed on to fully connected layers,
Okay.
kind of similar to what we saw with MLPs,
Gotcha.
to classify the digit.
It's really amazing how these CNNs
It is.
mimic the way our brains process visual information.
Absolutely.
Sounds like they're the superstars of computer vision these days.
They really are.
Mm-hmm.
I would think about the impact that they're having on medical diagnoses.
Okay.
CNNs can analyze X-rays
Uh-huh.
and detect these subtle patterns
Yeah.
that might be missed by the human eye,
Wow.
leading to earlier and more accurate diagnoses of conditions like lung cancer.
That's incredible.
Yeah, it's a powerful application.
Really using AI to potentially save lives.
Absolutely.
That's remarkable. So we've talked about visual data,
right.
but what about language? We
Yeah.
talked about sequential data before.
Uh-huh.
Can neural networks handle things like sentences and paragraphs?
That's a great segue.
Okay.
And that brings us to another type of neural network,
Okay.
recurrent neural networks, or RNNs.
RNNs. Okay.
Yeah.
What makes these different from the networks we've discussed so far?
Unlike feed-forward networks where the information flows in one direction,
Uh-huh.
RNNs have these feedback loops.
Okay.
They can remember past information,
Oh.
which is essential for processing sequential data where the order really matters.
So it's like remembering the beginning of a sentence
Right.
to understand the meaning of the end.
Exactly. Imagine a writing assistant
Okay.
that's predicting the next word in a sentence.
Okay.
An RNN would process each word,
Yeah.
keeping track of the preceding words to make an informed prediction.
So if I type, the cat sat on the...
Right.
the RNN would remember cat, sat, and on,
Exactly.
and suggest words like mat or chair.
You got it. It's analyzing that sequence and making predictions based on the context.
That's pretty impressive. But are there any limitations
Yeah.
to how much information these RNNs can remember?
You hit on a key point.
Okay.
Basic RNNs do struggle to remember information over very long sequences.
I could see that.
Imagine trying to remember a long grocery list
Yeah.
without writing it down.
Uh-huh.
You might forget the first few items by the time you get to the end.
Makes sense. So how did researchers address this?
Right.
Did they just give the RNNs a pen and paper?
Not quite,
Okay.
but they did come up with a pretty clever solution.
Okay.
Long short-term memory networks, or LSTMs.
LSTMs. Okay, what makes them special?
LSTMs were developed back in 1997 by Sepp Hochreiter and Jürgen Schmidhuber,
Okay.
and they're designed to specifically address this short-term memory limitation
Okay.
of basic RNNs.
So do they have some sort of enhanced memory capacity?
They do. LSTMs have a unique ability to selectively remember or forget information.
Interesting. So they can choose what to remember and what to forget.
It's kind of like having a control panel with gates that regulate the flow of information.
So these gates determine what's retained
Exactly.
and what's discarded?
Yeah, these gates allow LSTMs to handle much longer sequences than basic RNNs,
Uh-huh.
making them really powerful for tasks like speech recognition,
Okay.
machine translation, and even music generation.
Wait, music generation?
Yeah.
So these LSTMs are composing original music?
They are, by analyzing patterns in music.
Wow.
LSTMs can learn to generate new melodies and harmonies.
That's pretty incredible.
It's fascinating stuff.
So we've gone from simple perceptrons that are just making basic decisions
Right.
to networks that can recognize images, understand language,
Yeah.
and even compose music.
It's really amazing how far the field has come.
It feels like we're just scratching the surface here.
We are.
What about this whole deep learning revolution that I keep hearing about?
Well, that's where things get really exciting.
Okay.
Deep learning is essentially the era of these multi-layered neural networks,
Okay.
and it's transforming the field of AI as we know it.
I'm ready to hear more about this deep learning revolution.
Okay.
What makes it so revolutionary?
Imagine you're trying to teach someone to recognize different animals.
Okay.
With traditional methods, you would have to define a set of rules.
So you'd say like 4 legs for barks, that's a dog.
Exactly. But with deep learning, you take a completely different approach.
Okay, so instead of programming these explicit rules,
Right.
you're letting the AI figure things out on its own.
You get it. Instead of rules, you feed the AI vast amounts of data.
Okay.
In this case, images of various animals,
Mm-hmm.
and it learns to recognize patterns and make distinctions on its own.
So instead of making it memorize a dictionary,
Yeah.
you're showing it flashcards.
That's a great way to put it.
Okay.
And deep learning goes even further.
Okay.
It can distinguish between different dog breeds.
Uh-huh.
It can identify emotions on people's faces.
Wow.
It can even generate realistic images
Really?
that are indistinguishable from photographs.
That's incredible.
It is.
So it's not just recognizing patterns.
Right.
It's understanding them on a much deeper level.
You're getting it. And it's all thanks to those multiple layers.
Okay.
Each layer learns increasingly abstract representations of the data,
Mm-hmm.
gradually building this hierarchical understanding of the world.
This is fascinating.
It is. It's a fascinating field.
But when did this deep learning revolution really take off? Was
Yeah.
there a specific moment when everything changed?
There was a pivotal moment in 2012
Okay.
that really put deep learning on the map. It was the ImageNet competition,
Okay.
this large-scale image classification challenge.
So this was like the Olympics of computer vision.
You could say that.
Okay.
And in 2012, a deep convolutional neural network called AlexNet just blew away the competition.
Okay, what made AlexNet so special?
It didn't just outperform the other AI systems, it crushed them.
Really?
AlexNet dramatically reduced the error rate
Huh?
in image classification,
Okay.
demonstrating the incredible power and potential of deep learning.
That must have been a real game changer.
It absolutely was.
Hmm.
AlexNet's victory sent shockwaves through the AI community.
Wow.
And it really ignited this explosion of research and development in deep learning.
This is incredible.
It is.
I can't wait to hear about the latest advancements in deep learning and how these neural networks are shaping the future of AI.
Well, let's take a quick break and then we'll dive right back into it.
Welcome back. We've covered so much in our exploration of neural networks.
We have.
From those early days of the perceptron to this whole rise of deep learning.
Yeah, it's been quite a journey.
It really has been, and there's still so much more to discover.
Oh, absolutely.
I'm especially interested to hear more about natural language processing, or NLP.
Right.
We talked about RNNs and LSTMs.
Yeah.
But are there other types of networks that are really excelling in this area?
There is one that's making a really significant impact.
Okay.
It's called the transformer.
Transformer, that sounds intriguing.
It is.
What makes it stand out from the other networks?
Well, the transformer architecture,
Yeah.
which was introduced by Google researchers back in 2017,
Mhm.
is built upon this concept of attention mechanisms.
Attention mechanisms, that sounds almost human.
It does, doesn't it?
Is it similar to how we focus our attention
Yeah.
when we're reading or listening?
That's a great analogy.
Okay.
Just like we selectively focus on certain parts of a text or a conversation,
Right.
transformers can do the same thing with data.
Okay.
They can identify and prioritize the most relevant information within a sequence, which is crucial for understanding language.
So instead of just processing every word
Right.
or every sentence with equal weight,
Exactly.
it can really figure out what's important
Yeah,
based on the context.
you got it.
Oh, yeah.
Think about reading a long article.
Yeah,
You don't pay equal attention to every single word.
definitely not.
You naturally focus on those key phrases and sentences
Right.
that convey the main ideas.
That's true. I'd never get through my reading list if I had to remember every single little detail.
Exactly. And transformers have that similar ability
Whoa.
to grasp the essence of information,
Oh,
making them incredibly effective at handling these long and complex sequences of text.
So this has led to models like BERT and GPT.
It has.
BERT and GPT, those names sound familiar.
They do. They're getting a lot of press.
I think I've seen them in some articles
Okay.
about AI writing and chatbots and things like that.
Yes. Those models, which are powered by the transformer architecture,
Uh-huh.
are achieving state-of-the-art results in a wide range of NLP tasks.
Such as?
Translation, summarization, question answering,
Wow.
and even creative writing.
It's really amazing to think that AI is capable of
It is.
understanding and generating human language
Mhm.
with such fluency and sophistication.
It's incredible, isn't it?
It really is. But what about creativity?
Right.
Can AI truly be creative?
That's a great question, and it's one that has long intrigued researchers and philosophers alike.
Yeah.
And the answer increasingly seems to be yes.
Really?
One of the most fascinating areas of AI research that's exploring this very question
Okay.
is the field of generative adversarial networks, or GANs.
GANs! Okay, I'm definitely intrigued now.
Yeah, they're pretty amazing.
Tell me more about how they work.
Imagine a counterfeiter who's trying to create fake money,
Okay.
and a detective who's trying to spot those fakes.
Okay.
That's the basic idea behind GANs.
So it's like a constant game of cat and mouse.
You got it.
Okay.
You have these two neural networks
Uh-huh.
that are working in tandem. A generator, which creates data,
Okay.
and a discriminator, which tries to distinguish
Okay.
between real and generated data.
So the generator is trying to fool the discriminator,
Right?
and the discriminator is trying to catch the generator in the act.
Exactly. It's this adversarial process
Yeah.
that drives the learning and improvement of both networks.
So the generator gets better at creating realistic data,
Right.
and the discriminator gets better at detecting the fakes.
Exactly. It's a pretty ingenious.
Yeah, it's a really cool way to push the boundaries of AI creativity.
It is.
What are some of the things that GANs are creating?
Oh, the possibilities are astounding.
Okay.
They can generate photorealistic images,
Uh-huh.
compose original music, write different kinds of creative content,
Wow.
and even design new molecules for drug discovery.
I remember reading an article about a GAN-generated artwork
Yeah.
that sold at a prestigious auction house
That's right.
for hundreds of thousands of dollars.
It's amazing, isn't it?
Yeah, AI-generated art is becoming really popular.
It is.
It's blurring the lines between human and machine creativity.
It really is, and it raises some really interesting questions
Yeah.
about the nature of art
Yeah,
and what it really means to be creative.
it really does. So we've got neural networks that can see, read, write,
Yeah,
compose music, and even create art.
It's incredible, isn't it?
It really is. What other surprises
Right.
does the world of AI have in store for us?
Well, there's another paradigm in AI
Okay.
that's rapidly gaining traction.
Okay.
It's called reinforcement learning.
Reinforcement learning. Okay, how is that different from the other learning approaches?
So in supervised learning,
Uh-huh.
we provide the AI with labeled data,
Okay.
and it learns to map inputs to outputs.
Right.
But in reinforcement learning,
Yeah.
the AI learns through trial and error.
Okay.
It interacts with an environment, and it receives feedback
Okay.
in the form of rewards or penalties.
So instead of being explicitly taught,
Mhm.
it's more like learning by doing.
Exactly.
Figuring things out on its own.
Think of it like a child learning to ride a bike.
Okay.
They don't learn by reading a manual.
Right.
They learn by experimenting, falling down, and gradually getting better with practice.
That's a great analogy.
It is, isn't it?
So how does this apply to AI systems?
You have an agent,
Okay.
which could be a robot or a software program
Uh-huh.
that interacts with an environment.
Okay.
The agent takes actions,
Yeah.
and the environment provides feedback.
Okay.
If the action leads to a positive outcome, the agent receives a reward.
Mm-hmm.
If it leads to a negative outcome, it receives a penalty.
So the agent's trying to maximize rewards
Right.
and minimize penalties.
Exactly. And over time,
Yeah.
the agent develops strategies that lead to the most favorable outcomes.
Makes sense.
One of the most famous examples of reinforcement learning
Okay.
is DeepMind's AlphaGo,
Oh, yeah.
which made headlines back in 2016
I remember that.
when it defeated the world champion Go player Lee Sedol.
It was a huge milestone. It was in the history of AI.
Absolutely.
So AlphaGo learned to play Go at such a high level just by playing millions of games against itself.
That's right. It started with no knowledge of the game
Wow.
and gradually learned through reinforcement learning,
Okay.
experimenting with different strategies,
Mm.
and refining its approach based on the feedback it received.
That's incredible.
It is, isn't it?
So where else is reinforcement learning being applied?
It's being used in a wide range of fields.
Such as?
Optimizing energy consumption in data centers,
Okay.
controlling robots in complex environments,
Mm.
personalizing educational experiences,
Wow.
developing new strategies for financial trading,
Okay.
and much more.
The possibilities really seem endless.
They do.
But where do we go from here?
Right.
What's the future of neural networks and AI?
That's the big question, isn't it?
It is.
We've made incredible progress
Yeah.
in recent decades,
Yeah.
but we're still in the early stages
Okay.
of understanding both artificial intelligence and the nature of intelligence itself.
So this quest for artificial general intelligence, or AGI,
Right.
machines that can really learn and reason like humans,
Yeah.
it's still ongoing.
It is absolutely. There are many challenges ahead,
Okay.
but the pursuit of AGI is driving some
Yeah.
of the most exciting research in the field.
What are some of the key hurdles?
Well, one of the biggest challenges is developing AI systems that can learn from very few examples,
Okay.
just like humans do.
Right.
Current AI systems often require these massive amounts of data to learn effectively.
Makes sense.
Another challenge is enabling AI to understand cause and effect,
Uh-huh.
not just correlations.
Okay.
We also need to develop AI systems
Yeah.
that can process multiple types of sensory input,
Right.
vision, hearing, touch.
Just like our brains do.
Exactly.
It sounds like replicating the full complexity
Yeah.
of human intelligence is still a long way off.
It is, but the progress we've made is remarkable.
It really is.
And who knows what breakthroughs await us in the future.
Right.
The field of AI is constantly evolving.
Yeah.
And it's an incredibly exciting time
Yeah.
to be witnessing these advancements.
This has been an incredible journey
It has.
through the evolution of neural network.
It really has.
It's clear that this field is pushing the boundaries of what's possible
Absolutely.
and shaping the future in profound ways.
It really is.
From those simple models that were inspired by the human brain
Right.
to these complex systems capable of creativity
Yeah,
and strategic thinking, neural networks are transforming the way we live and work
they are.
and interact with the world.
I couldn't agree more. And it's important to remember that we're only just beginning
Yeah.
to explore the vast potential of neural networks and AI.
Absolutely.
Who knows what amazing applications and discoveries lie ahead?
That's right.
It's a journey filled with both challenges and possibilities.
Yes.
And it's one that I'm incredibly excited to be a part of.
Thank you so much for guiding us through this fascinating world.
My pleasure.
It's been a really enlightening experience.
Good.
And I'm sure our listener is ready to keep exploring this ever-evolving field.
I hope so.